Welcome to Section 6, Part 1, where we start looking at our entity AI. The reason why we're starting to look at AI at this point is AI is required for the movement of AI characters. So as we head towards getting our entities to move around, we're going to need some AI set up. So the first thing I just wanted to cover was just a bit of information about the components that make up the AI. I'm going to start with the AI controller. So the AI controller is considered the brain of the AI, where it's the component that allows the AI character to make decisions, move around, and interact with its environment. And the difference between an AI controller and a player controller is more like the essence of the human player at the other end and handles their input and possession of pawns, where the AI controller handles the possession of pawns as well, but hasn't got that human input or input from another source. So it has to handle sort of environmental and game world logic to make decisions and react. So by default, the Unreal AI controller manages navigation, perception. It has a behavior tree and a Blackboard. Behavior tree is sort of like the actual brain, makes the decisions. All these components are used to interact with the environment and the world around the AI character in an automated way. So it doesn't require human input to try and get that perceived responsiveness and a live-like movement from the AI. So the behavior tree is where those decisions happen. So the definition of a behavior tree is a mathematical model of plan execution. It's essentially a network of logical decisions referred to normally as nodes, and the final result of those nodes is a plan or some kind of what you'd normally hear it called an action, and that's what the AI will actually carry out after the decisions are made. So the behavior trees in Unreal Engine uses a graphical interface, which makes up a representation of the decision-making logic, and it allows developers to visually script AI behavior using the tree-like structure. So the nodes in the tree represent tasks, services, and decorators. So they're common terms you're going to hear when you're working with behavior trees. And the tasks are just the actions that the AI can perform, so the end result of the logic. Services are background checks or updates to that logic. So they normally run in the background and update the logic that the tree is checking. So that, like there's going to be information coming from the environment or other things that will come on, like perception or whatever, but the services can update those logic values on the fly in the background. And then you have decorators, which are the condition checks at the branches of the tree. So when you're traveling down the tree and come to 2 branches or more, you have to decide which branch to take. So that's where the decorators come. It's usually just a logic check of some kind. Is this true? Take this branch. False, take this branch. So what the behavior tree then makes up is sort of a roadmap guiding the AI character's actions based on the conditions of the world or the priorities of the AI character at the time. So a key component of the behavior tree is the Blackboard component, and it's called Blackboard because the AI uses it like a chalkboard to jot down important information. I like to refer to it as the AI's memory, where it remembers things that it can then do all these checks against. In reality, the Blackboard is a storage system for variables. AI uses those variables to make all its decisions. So the decorators check logic against these variables, at branches in the tree like we talked about, and it's all referencing the Blackboard. So the behavior tree's configurable logic tree that you can do is then influenced by the environment or the world events as these variables update on the Blackboard. And then the AI character makes resulting actions, and it seems responsive and alive because it's all based on what's happening around the AI character. Now, the AI needs to get this data from the environment, and there's a couple of ways you can do that. One of them is perception. Perception can be used to get information from objects in the world by simulating perception sensors. So the perception sensors we can configure in Unreal are sight, noise, and damage to self. So you're sort of configuring, each sense requires specific configuration, both on the AI sensing and the object projecting the sense. So if you look at something simple like the sight sense, it can't see things that aren't telling the system that they can be seen. So you need to configure both ends. But the perception system is highly customizable and generally needs some sort of system implementation to handle the resulting sense data in the background. It could be simple or advanced depending on your needs, but it's generally going to need something to just get those perceived data, work it to how you need it, and then feed it to the Blackboard so it can make decisions on what it's seeing. The other system for getting environmental data is called the environmental query system. Often you'll hear it just referred to as EQS. And that allows queries of the game environment through use of tests. Works by a process of elimination. So each test will eliminate things that don't equal the desired result until it gets down to the single best result or a short list, depending on what you need. So the query begins with a generator that establishes the locations or actors to be tested, and then another term you'll hear is context, and they provide a reference to what to test each generated location or actor against. Although the environment queries can be used outside of the scope of AI, query the environment, they're often used with AI for the purpose of the AI reading the environment and reacting to the environment. Environment queries can be used directly in C++, but they're most commonly used in behavior trees. So the behavior tree by default in Unreal Engine comes with a node to execute a behavior tree and store results down to the Blackboard. The EQS system is highly optimized to carry out these checks. There's a number of methods it uses to optimize the queries. The primary one is just culling, so elimination of irrelevant objects or locations that are not going to meet the requirements straight away. It also uses parallel processing, so the use of multi-threading, and it will cache queries that are being used over and over or bunch in a row or something like that. It can throttle queries as well, so it won't just smash the system when it's got a massive query to do. It'll separate it out over multiple frames. And it can do spatial partitioning, so using octrees and spatial hashing, it can sort of divide queries up into quadrants and do them that way. That's all happening in the background. You don't really need to worry about that. The only thing you really want to think about is when you're building a query and you're putting in your tests, you want to do the tests that eliminate the most first. So what's something simple? So you could just say, if it's not within 50 meters of my AI character, eliminate those positions. Or if I don't have line of sight, then eliminate those positions. And it's getting rid of. You want to get rid of the most generated sources that you're going to check against as you can, because then it just reduces your checks tenfold and makes it quicker also to get down to what you need. So that's some AI components in a nutshell. There's plenty of documentation out on all of these, and I'm barely scratching the surface about what they can do, really. We'll be using some of them. We're going to set up perception. We'll probably at some point do some environmental queries. We're definitely setting up an AiController and a Blackboard and all that, so behavior tree. But the first thing I want to do is we're going to set up our AI data assets. And I just want to quickly explain why I'm just using a data asset for AI and not just configuring an AI controller with the data in there. And the reason for that is we can sort of create plug and play type AI characters. So if you imagine we've got two characters, but we want very different behavior, all that we've set up, but just plug in a different AI data and that can change. So what's an example? So the perception system uses a radius to see how far they can see and how far they can detect enemies. So say you have two characters, one's a sniper, one's a normal soldier, and the sniper can see heaps further, but maybe in a limited cone or something like that because he's using optics. You can just have a separate AI data asset and just plug that in. So the two characters could be exactly the same, except for the AI brain that's going in and the perception system. And it's totally configurable like that. And it just makes our AI independent from the entity data, really. That'll do for a quick little intro to AI. Let's get into coding our AI data asset. Starting out in the code, we're going to go straight to, we're in RTS entity still, and we're going to go to data, and we're going to create an AI data. That will inherit off the primary data asset. And we can cheat a little bit and go to our entity data asset, grab this up. Close the CP. That's all the same, that's fine. And once properties, edit. And these will be, we'll do our settings for our perception first. So put that under category perception. First one we're going to want is a radius. And I'm going to set defaults for this. So use whatever values for that you want. Know what you commonly use in your entities. Set that up there. So now we're going to need a bunch of these. So we're going to need a lose site radius. We're going to need a angle, site age, and we need some bools for like, do we detect enemies, friendlies, or neutrals? Do those first. So the first one was lose site radius. I really haven't played with these numbers a lot, so just be aware that they use more. This one, I'm going to call this peripheral vision angle. And I'll mention that it's degrees. Hearing it won't get confused. So that's 85 because I want them to have like 20/20 vision by default. This one will be site age. So how long do they remember a target after they see them? These ones are going to be bull. Friendlies. And I'm going to put enemies to true and rest to default. Now there's just one more setting actually. Float. And it's the auto success range. It's called auto success range from last seen location. Even if the enemy's behind a wall or not in line of sight, if it's within a certain distance from the last seen location, then it'll perceive it straight away. So let's just call it exactly that, so there's no confusion about what it is. Long name, and I might just default this to 200. If they're super close, then proceed. Right, that's good for perception now, so we'll just copy this. And we'll go on to our behavior tree called behavior. And in here we want a soft object reference to our U behavior. Now I'm calling it Australian/English way here, so it's not finding it. How do you spell it? It's IOR, I believe. So you need to include the input behavior for declaration. Nope, that'll just be the behavior tree where we start using behavior. That'll actually be the editor file for the behavior tree we'll create when we get into the editor. And the last setting that we're going to have here, I'm going to put this under configuration. And this is just a reference to the AI controller we want to use. This will be an actual soft pointer to a class, like a blueprint class. And we don't have our own class yet, so I'm just going to put the generic controller class here. Add some. Oh, yes, I'm adding the forward declaration at the top. I just noticed that that is wrong. It should be U behavior tree. Sorry, I did not notice it. Right, glad we caught that now. All right, so this will just be AiController class. And that's what we'll use to assign to the AI when we. So let's create our class so we can update this. I'm going to come under. I'm not going to put it under entities. I'm actually going to put it under an AI folder here. It's going to be the base class. So it's the usual cleanup. We want a object initializer for this. So let's copy that from somewhere. And you do this like 1,000 times now. Group, entity data. So now let's, for short memory forgets, let's update that. It has to be a base class of our type. So yeah, I close the entity data, but we actually need to, in the entity data, we want to assign AI data. So let's put it under, and it'll just be a primary asset. AI data. And then just so it's only limited to, so we can only select a primary asset that's AI data, put in the meta. Like so, kind of quotes around that, doesn't need it because there's no spaces in the name. That should be fine. So now we can assign our AI data to the entity data. So the next thing to do is when we do the process of loading what entities we're using, we want to load the AI data as well. And if you recall, we did that in the loadout manager. So we have our entities loadout component. On the player entity data loaded is where we need to handle. We need to change this to grab the AI data and load that. And then when that is done, then we call the create groups. So back in here, I'm going to create a new function, U function, that's going to be called from when the entity data, after the entity data loaded, we'll get the AI data, we'll load that, then this one will be called. And I'm just going to call this one loadout data, loaded. Everything's loaded. All player loadout data loaded. And that should be the same. So we're going to pass the group assets still, because that's what we need to pass to create groups. Move this down to here. Then the on player entity data loaded now. We'll put authority. Copy some stuff. We're going to need a reference asset manager. I'm going to create an array of entity AI assets now. So we need to pass that in now. That's all one change need to make with data. Need to pass all entity data assets and on TL. Okay, and now we want to cast it to our entity data. That'll be primary asset data object. And we just want to add that to the, so we want to retrieve the entity AI asset and add it to our list. Probably should check that that is valid first. And let's actually put a log in here that will tell us that in the log, so we see that we are done right, even though nothing will error. So in log temp, error. I usually do something to recognize the class that it's coming from, so if you get the log, you find it again, and we'll just say AI data. For this first one, we'll just do a class. So that'll build up our list of entity AI data, and now we want to load it. So probably deal this load. Assets there. Be on all player. I want it to go to that function. Like constant or modified data. And that should be it. There's no bundle stuff. So when the AI data assets are then loaded, then we'll create our groups. So we've got our AI data asset created. We're loading it when the game launches, and now we need to create it in when we create our entities. We'll do in the next part. See you there. Thanks for watching.